Time to talk about quadratics. I expect this to be quite a quadratical discussion. First things first, what is a quadratic? A quadratic is a polynomial, meaning a series of terms of x and its various powers, such that the highest power of x that appears is x squared. Okay? An example is given here. So we have an expression involving x, a constant term, and x squared. Another example would be something like, I don't know, g of x equals x squared minus 7. Right? Here we don't have an x term, but still the highest power of x that appears is an x squared, so that's also a quadratic. Another example would be, I don't know, 5x squared plus 6x. Here we don't have a constant term. We don't have a number at the end, like these polynomials, but still the highest power of x that appears is x squared. So that's a quadratic. Now the problem that we're mainly concerned with is finding roots or zeros of quadratics. An example is given by this problem here on the board. We want to show that 7 and -5 are roots, aka zeros, of this f of x, which is x squared minus 2x minus 35. So what is a root or a zero? Well, that's just a value of x, such that if you plug that value in for x, you get 0 for f of x. For example, let's say we want to do what we want to do here. We want to show that 7 is a root of f of x. Well, then we just plug 7 in for x. So f of 7 is 7 squared minus 2 times 7 minus 35. 7 squared, 7 times 7, that's 49. 2 times 7, well, that's 14. So this evaluates to 49 minus 14 minus 35. Well, negative 14 minus 35, that's negative 49. So this is 49 minus 49, which is 0. So since f of 7 is 0, that means that 7 is what we call a root or a 0 of f of x. Got it? All right, let's try -5. So f of -5 is -5 squared minus 2 times -5 minus 35. So -5 squared, -5 times -5 is positive 25. Remember, negative times negative is a positive. Same here, -2 times -5, positive 10. So this is 25 plus 10 minus 35. Well, 25 plus 10 is just positive 35. So this is 35 minus 35, aka 0. All right. So at this point, we've shown that both 7 and -5 are roots or zeros of f of x, because when we plug them in, we get 0. Now, a natural question arises, and maybe you already asked it yourself. Are these the only roots? Or are there other values that if we plug them in for x, we get 0? Well, let's try a few. Maybe I could take 1. So f of 1, 1 squared, minus 2 times 1 minus 35 That's 1 minus 2 minus 35. So 1 minus 2 is negative 1. Minus 35 is negative 36. Well, that's not 0. What about another one? Maybe negative 3? Let's try that. Okay, so f of negative 3 is negative 3 quantity squared minus 2 times negative 3 minus 35. Negative 3 times negative 3 is positive 9. Negative 2 times negative 3 is positive 6. So we get 9 plus 6 minus 35. Well, that's just 15 minus 35, which is negative 20. Again, that's not 0. Oops. So, these weren't very good guesses. Or maybe there aren't any good guesses. Maybe there aren't any other numbers besides 7 and negative 5. If we plug them in, we'll make 0. In fact, that's the truth. 7 and negative 5 are the only roots of this quadratic. And in fact, for every quadratic, there are at most 2 real roots. But how do we know this for sure? And how do we find these roots? Stay tuned and you'll find out. But first, a brief interlude. Foiling. This should be a review, but it can be helpful. So the word FOIL is an acronym. That's a word where the letters stand for stuff. So in the case of FOIL, the letters stand for first, outer, inner, and last. So this is a reminder that helps us when we're simplifying the product of 2 binomials. Okay, so an example would be something like 3x minus 1 times 2x plus 3. These are called binomials because each of these has 2 terms each. Binomial. Bi means 2. Nomial, I assume, means terms. I don't know for sure. Anyway, to simplify or expand this expression, we use this acronym FOIL. The idea is that to multiply this out, we need to take the product of every term in the first binomial times every term in the second. For example, the f in FOIL is first. So the first 2 terms are 3x and 2x. So their product is 3x times 2x, which is 6, because 3 times 2 is 6, and x squared, because x times x is x squared. Okay? The next term, outer, refers to the 2 outer terms. In this case, 3x and 3. So 3x times 3, 9x. Inner refers to the 2 inner terms. In this case, negative 1 and 2x. So negative 1 times 2x, negative 2x. And last, of course, the last 2 terms. So negative 1 times 3 is negative 3. Are we done yet? Not quite. We have 2 like terms coming from the O and the I, the outer and the inner. And we can combine or simplify those. So 9x minus 2x is 7x. So this simplifies to 6x squared plus 7x minus 3. Makes sense? All right, let's do another one for more practice. 5x plus 2 times 2x minus 1. Okay, f is first. First times first. 5x times 2x, well, 5 times 2 is 10. X times x is x squared. Outer, the two outer terms. 5x times negative 1. That's negative 5x. Inner, the two inner terms. 2 times 2x, that's positive 4x. And finally, last, 2 times negative 1 is negative 2. As usual, the O and the I, the outer and the inner terms are like terms, so we can simplify them. Negative 5x plus 4x is negative x. So our final answer is 10x squared minus x minus 2. Any questions? All right then, let's do one last foiling example just to make sure we got the hang of things. We'll do 7x minus 3 times x plus 5. Okay, first times first. 7x times x, 7x squared. Outer times outer. 7x times 5, well, 7 times 5 is 35. And there's an x there, so that's 35x. Inner times inner. Negative 3 times x is just negative 3x. And finally, last times last. Negative 3 times positive 5 is negative 15. As usual, we combine like terms, the outer and the inner. And here that gives us positive 32x. So our final answer, 7x squared plus 32x minus 15. All right, I think you got the hang of things by now. One more brief interlude before I show you how to factor and therefore solve quadratic equations. Question: can we find non-zero numbers a and b such that a times b is 0? I don't know. Let's think about it. So let's say I want a times b equals 0. Well, I could take a to be 0 and b to be 3, right? 0 times 3 is 0. Or I could take a to be negative 7 and b to be 0, right? Negative 7 times 0 is 0. And I could even take them both to be 0, because 0 times 0 is 0. But these aren't really answers to this question, are they? Because I'm looking for non-zero a and b with a times b equals 0. And when I think of non-zero numbers, when I multiply them together, I'm not going to get 0. For instance, if I do negative 3/5 times 1/2, well, multiplying across, that would be negative 3/10. That's not 0. And in fact, no matter which non-zero numbers I chose for a and b, I would always have a times b non-zero. So the answer to this question is no. Whenever I have a times b equals 0, either a is 0, b is 0, or they're both 0. And otherwise, I will not have the product equaling 0. All right, on to factoring.